Question 2 is a binomial and integration question. These two things quite often get put together in the exam. So we start off with just an integration. Now don't forget your core 1 integration when you do this question. So we're going to integrate 1, that goes to x. Now we're going to integrate 3x squared, 3x to the half, so increase the power by 1 and divide by new power. Then we're going to do the same with x to the 3 over 2. 3 over 2 plus 1 is 5 over 2, divided by 5 over 2. For this question, you didn't actually have to simplify, but if you do, you want to make sure we get it correct. So that's x plus, now if you're not sure how to do 3 divided by 3 over 2, you can always do this in your calculator. So 3 divided by 3 over 2, it will tell you the answers to. For if you need to do that by hand, that's 3 times 2 over 3. Remember, it's keep the first number, change the divide to a multiply, and flip the second fraction. We're dealing with dividing by fractions. So that's 2x to 3 over 2, and then dividing by 5 over 2 is the same as multiplying by 2/5. There's one thing that I've just realised I have forgotten on this question that we should always do when there's no limits, which is have a plus c. Okay, so then it appears we're going on to a binomial expansion. So in part B, part 1. So it tells us the expression y plus 1 plus y cubed can be written in this form, and then wants to write down the value of the constant n. Now that means you don't have to show any working. So if you can remember that from this form, those are just the coefficients in Pascal's triangle, or you can remember that it goes 3, 0, 3c1, 3c2, 3c3, you can just write down that n equals 3. If you're not sure, you can go to your formula book and find the binomial series, and then we can just do this expansion to find out. So we've got a is 1, b is y, and n equals 3 for our expansion. So 1 plus y cubed is 1 cubed plus 3, remember this is 3c1 on your calculator, times 1 squared times y plus 3c2, so the number goes down, power goes down on a and goes up on whatever b is, and then we get to the point where it's 3c3, a to the power of 0, b to the power of n, which is b cubed, and then we can simplify that. So 1 plus 3y plus 3y squared plus y cubed. Using your calculator if you need to work out these bits. So for example, 3, shift C2 will give us the coefficient in front of the y squared. And then we mustn't forget to answer the question and write out that n was 3. Okay, so then they want us to use that. Now there's a key word in this part of part 2, which is hence. It says hence or otherwise. Now, usually that means that hence is the easy way, or otherwise is the long way. The or otherwise is to use the binomial expansion again. But let's do this using the hence, because that's a bit of a clue. It's probably a quick way to do it. Well, we have a look at B part 1 and part 2, and we notice that the only difference is that instead of y, we've got the square root of x. So all we need to do is to take our answer to be part 1, okay, or if you haven't written it all out, it's in B part 1 in the question, and replace y with the square root of x. So it's 1 plus 3 square root x plus 3 square root x squared plus square root of x cubed. Now in this case, that's all you need to do to get 1 mark. There's only 1 mark. Some people did then simplify that, and if you did want to simplify that, that's 1 plus 3 square root x plus 3, so a square root and a square inverse functions, that's just x. And then lots of people recognise that square root of x cubed is x root x. But that wasn't necessarily for 1 mark, there's only one. Right, now this is really important in part C because it says hence. Now that's a big clue that we're going to be using some of the things we've done before. So we've got 1 plus cube root of x, square root of x cubed. Now you don't yet know how to integrate that directly, so we must be using the clues in the hence, something we've already done. So in part 2, we expanded that out. So this integral is the same as 1 plus 3 square root of x plus 3x plus x root x, or you could use that in the other form. And then this is core 2. What do we need to do with the square roots? Well, we need to change all these to powers before we can integrate. So into index form. So a square root is a power of a half. An x root x, or a square root cubed, is an x to the 3 over 2. That's a good one to remember because that comes up a lot. Okay? So you've got x times x to the half, and when you multiply them, you add the powers. So that's x to the 1 over half, 1 and a half, which is 3 over 2. Or the other way to think about it is using our square root cubed. So that's x to the half cubed. And we've got a power to a power. That's the same as multiplying the powers. So there's 2 ways you can see that works. Now, one thing that lots of people forgot then was they replaced it and they forgot that the question this integral sign at the front, and they forgot to integrate. So make sure we actually integrate this. There is also a bit of help in the question, because if you go all the way back to part A, in part A we've already integrated 1 plus 3x to the half plus x to the 3 over 2, and we've got almost exactly the same except with a 3x term in it. So we've already integrated this once in the question. So that's going to integrate to, we had 1 integrated to x, we had 3x to the half, integrating to 2x to the 3 over 2, in part A, all the way back to part A. Then we've got a new term, we've got 3x, increase the power by 1, divided by new power. And then we had x to the 3 over 2, well that went to x to the 5 over 2, and then that's 2/5. In this case there's no plus c because we've got some limits, we've got 0 and 1. It wants the exact value, so I need to make sure at the end that our answer is a fraction or a third. So let's see, or an integer. Right, once you've done that we need to substitute the limits in. You should show this step to make sure we get all the marks. So substituting 1 plus 2 times 1 to the power of 3 over 2, well 1 to the power of anything is 1, so we can save some effort by not writing that down. 3 times 1 squared is 1, so that's 3 times 1 over 2, and then similarly with 2/5 times 1 to the power of 5 over 2. Now if you substitute in 0, we're just going to get 0, because everything's got an x in it, so 0 times anything is 0. Okay, so what have we got now? At this stage, I haven't tried this out, it might work if you just put it in your calculator. So I've got 1 plus 2, which is 3, plus 3 over 2, plus 2/5, which is 49 over 10, or you can equally well have 4.9. The integration is not core 1, but that level of substitution could be in core 1 when you'd have to do it without a calculator.